Hey everyone, this is a lesson on exponent laws. I've split this lesson into two parts, so this is exponent laws part one. We are going to be using exponent laws today. This is a topic you visited last year in math, so hopefully today is a little bit of a review for you, but we are going to be including some of the new things from Math 10, which are negative exponents and fractions as well. When we do today's lesson, I'm just going to kind of go over what we'll be doing first before we start writing anything down, just because the page looks a little bit complex here with all the boxes and numbers and letters. So in with exponent laws, there are three main laws. So we're going to go over all three of those. So I'm going to use different colors to highlight. So the first one we'll do is the product of powers. And when you do the product of powers, you add the exponents. So when you have two powers with the same base, you end up adding the exponents, and we'll talk about why that works. Next, we are going to do exponent law number 2, and I'll use blue for this one. And in exponent law number 2, when we're dividing two powers with the same base, we end up subtracting the exponents, and we'll talk about why that works. And then finally, we'll do exponent law number 3, which is, I'll do it in pink here. And that one is a power of a power law. So when we have one power and then another power of that power, we end up multiplying the exponents. And we'll talk about why that works, and we'll do some examples. Then finally, at the very end here, we will combine all the laws together and do more than one law at one time to evaluate some expressions, okay? So let's talk about law number 1 first. This first law is called the product of powers. And so we're multiplying two powers that both have the same base. So let's look at an example. 10 to the power of 2 times 10 to the power of 3. Let's look at why we would want to add the exponents. 10 to the power of 2 is 2 tens multiplied together, right? And 10 to the power of 3 is 3 tens multiplied together. How many tens do we end up having? 1, 2, 3, 4, 5. 2 plus 3. So that's why that rule works, is because you end up adding these numbers when you add up all the tens that are being multiplied together. So this would actually be 5 tens. And so the answer, if you were going to evaluate it, would be 1 with 5 zeros, so 10, or 100,000, sorry. There we go. Okay, so we're going to write these as a single power. That means apply the rule and write it as a single power. And then we are going to evaluate, which means answer the question. Okay, so let's do the first one. This is 2 to the power of 3 times 2 to the power of 2. So the bases are the same. We're going to add the exponents. So that would become 2 to the power of 5. Now we'll answer the question. If you multiply 5 2's together, you get 32. Okay, so this is the single power part, and this is the evaluate part. Okay, let's do the next one. So this one, we have 4 to the power of negative 5 times 4 to the power of 7. We are going to add those exponents together. We get 2. And now we're going to answer it. 4 squared is 16. 4 times 4 is 16. Okay, and last one is a fraction. We are going to add these two powers together, and it would become negative 3. Now if we're going to answer this, I might have to go a little bit outside the box here. So remember, a negative 1 means flip. Negative exponent means flip the number or divide by that number 3 times. So it's going to be 27 over 125. So this was here the answer written as a single power, and then we evaluated it to be 27 over 125. Okay, let's do law number 2, which is quotients of powers. So we are dividing two powers with the same base. We will show how it works with this example here. So let's say I had 10 to the power of 5, which would be 5 tens, and 10 to the power of 2 on the bottom. So when we have a fraction, we can cancel things out if they match on the top and the bottom when we're multiplying. So we actually end up with 3 left over. So we subtract 2 of them off because we've canceled them out, and so we end up with 10 to the power of 3. So that's why the subtraction rule works, is because you kind of cancel those out. Okay, so let's practice doing that with some examples below. So again, here we're going to be subtracting these exponents. So for this first example, we're going to have 2 to the power of 3 because 7 minus 4 is 3. So that's the number written as a single power. And then we're going to evaluate 8. Okay, let's do another one. 3 to the power of negative 1 divided by 3 to the power of 3. So we're going to have negative 1 minus 3, which is 3 to the power of negative 4. So that's the number written as a single power. And we're going to evaluate it. So when we do this one, we're going to flip it. Oops, sorry, my pen went a little wonky there. There we go. 1 over 3 to the power of 4, so 1 over 81. When you multiply 4 3's together, you get 81. Okay, last one. Again, we're dividing here, so we're going to subtract. Careful with negatives when you're subtracting. Some students kind of miss this. You're subtracting a negative 4, so actually you're adding 4. 2 minus negative 4 is actually 6. And we're gonna, when we evaluate this, all it would be, so we can change it to a fraction. It might be easier for you to evaluate, and you're just going to multiply 6 1's together, that makes 1, and then 6 10's together, so it'd make 1 million. Make sure I wrote down, yeah, there we go. So here's the number written as a single power, and then the answer would be 1 over a million. Okay, or 1 millionth. Last one, power of a power law. For this one, we are multiplying. The reason we multiply in this case, I'll show you why it works, is because we're doing 10 squared, which is 2 10's, all to the power of 3. So I'm going to have 3 groups of 2 10's. So that would actually be 6 10's altogether, which is the same as 2 times 3. So that's why that kind of works. It's like 3 groups of 2 10's. So 1, 2, 3. So it is actually 10 to the power of 6. So you do multiply the powers, or the exponents, sorry, when you have a power of a power. Okay, so let's do these examples. You can pause here and do these on your own if you want some practice, but I'll go through them as well. So we're going to multiply those. So we get negative 6. Negative exponent just means we flip the number. So this would be 1 over 64. Okay, next one, multiply. 6 times a half is 3. And evaluate it, be 64. Okay, last one, again, multiply. Okay, so you end up with 5 over 3 to the power of negative 3. We actually did that up above a couple steps ago. So we flip the number and multiply 3 times. So it'd be 27 over 125. Okay. Take a breath. Okay, we're going to finally, so just kind of reviewing what we just did. We did 3 laws. So we have a product of powers law. So that's where we add the exponents. We have a quotient of powers law when we subtract the exponents. And we have a power of a power law where we multiply the exponents. It's important to recognize when to do each of these 3. And these are the only 3 laws that you need to know. And now we're going to be doing questions where we have to use more than one of these. And I'm going to keep these colors consistent. So I'll use yellow for exponent law 1. I'll use blue for exponent law 2. And pink for exponent law 3. Okay, let's do this first one here. So this one, we're going to be combining exponent law 1 because we have a multiplication of 2 powers on the top. So let's do that first. So I always like to do everything that's on top of a fraction or on the bottom. If you can simplify that first, we do that. So let's go ahead and do that first. So this would be 5 to the 5. So I'm just going to write in pink here what I did. I did exponent law 1. And I'm going to highlight it in yellow here. Now we're dividing 2 powers of the same base, so we're going to go ahead and subtract. We're going to do exponent law number 2, the one we had in blue. So we're going to subtract these 2. So we get 5 to the power of negative 2. And finally, we're going to evaluate. So that would be 1 over 25. Okay, next one. What I always tell students is you want to work inside the brackets first. Don't worry about that negative 2 sitting out there until the very end. inside the brackets first, like follow BEDMAS, do brackets first. So in this bracket here, I can see that there are two powers being multiplied. So I'm going to use exponent law number 1 first and combine those two. Okay, just focus in on one part at a time. Don't get overwhelmed by all the other numbers. I'm just going to write everything else. And on the bottom there of that fraction, I'm going to have 0.7 to the power of 5, okay? Because I added the 2 and the 3. Next, focus in, okay? Focus in inside the bracket. I can see there's a division happening there, so I'm going to use law number 2, where we subtract the two exponents. Okay, so don't worry about anything else, just focus in on each part one at a time. So that would be 0.7 to the negative 1, because you subtract 4 minus 5. And finally, we have a power of a power. So we are going to be using law number 3. And I'll just kind of go in a circle here. Law number 3. Okay, so we're going to be multiplying those two numbers. So we get 0.7 to the power of 2. We're done. Much simpler now. And now we just get to evaluate. And when we evaluate, I think it's much easier to change it to a fraction. So 0.7 is the same as 7 over 10. So we go 7 times 7 and 10 times 10. All right, so that's it. So again, my advice for when you're doing these combining of laws, especially with these complicated ones with brackets, go zero in on what you're going to do first and always work inside the bracket first and then work with any numbers outside the bracket. So here we simplified these two in the denominator here, and then we simplified the quotient, and then finally we did the power of a power law. Okay, that's the end of the lesson. Next kind of half of this one, we're going to be doing the same 3 laws but with variables instead of exponents, so with letters instead of numbers.